Hello students. Today I am going to take a topic on this sampling theory. So in this sampling theory, what is sampling theory? Why do we use samples? See, whenever it is difficult to test for the entire population, the population is a whole. The items, total items, you refer to the population. So whenever it is difficult to find uh, any particular statistic or any particular thing in a population, you divide it into small samples. So a population, I already told this, population is whole, that is full, and in this you can take different small samples. So sample 1, sample 2, sample 3, sample 4. So whenever it is difficult to study a population, you split it into samples. That is, you take only a part of it, test whatever you require for that, and whatever value you get for the sample, we generalize it for the entire population. For example, if you are cooking a rice, if you cook a rice, it is not easy to check each and every grain of the rice. So in that case, you just test one or two particular grains and see whether it is cooked, and then you think, if it is cooked, you think that the entire rice bowl is cooked, and you generalize it for the entire bowl. So in whenever you want to test your blood, you just take a blood sample. Will not test the blood in the entire body. So you only test for a particular sample, and whatever result you get for that particular sample, you generalize it for the entire blood in the body. So that in such cases you use sampling. So whenever it is not possible to test entire population, you test the sample, and whatever result you get for the sample, we generalize it for the whole population. So here in this sample, we go for the next topic, that is sampling distribution. So here sampling distribution, that means here you compute mean, standard deviation for each sample. That means suppose I have 10 samples, I test, that is I find the mean of all the 10 samples. I can test standard deviation of the 10 samples. So whatever you are testing, that will not be the same for all the samples. It will vary. So from sample to sample, most probably it will be the range will be nearer, but it will vary from sample to sample. So now coming to this sampling distribution of statistic. Statistic here means whatever values you find for the sample, you call it as statistic. Suppose I am finding mean of a sample, that you call it as a statistic. If you are finding median, if you are finding standard deviation of a sample, that particular thing you call it as statistic. Mean, statistic means these are the items, or these are the things what you check for the sample. So here sampling distribution of statistic means this is like a frequency distribution. Already you know the frequency distribution. Suppose I have 10 samples, I will check whatever I want for that 10 samples, and I write it the values, and I frame it as a frequency distribution table. Same way here, this sampling distribution of statistic is same as a frequency distribution. So this is the probability distribution of all possible values of a statistic is a distribution of the sample statistic. That means it is a probability distribution of whatever values you find for a sample. So here the standard deviation, that is sampling distribution of statistic, means this is a frequency distribution which is formed with various values of statistic. Like you are taking different samples. So suppose I find mean, suppose I find median, whatever I have found, the different values of the samples which you have drawn from the same population is a sampling distribution of statistic. So suppose here is statistic means, I told you, any measure of the statistic, any measure of sample, you call it as statistic. Any measure of a sample, you call it as a statistic. So here it may be a mean, median, variance, anything. So the series of these various values of statistics, whatever you obtain, will be arranged in the form of frequency distribution, that is called sampling distribution of statistic. Now we move for the sampling distribution of mean. So whatever probability distribution of all the means of the samples, that means suppose I take the first mean, so first sample mean, so I get one particular value. I take second sample, I'll calculate its mean, I'll get some particular value. So I just put them as the values. Suppose my sample here size is 8, again next sample size is 10 for example, again I find the mean of all these 10. So the probability distribution of all possible means of the samples of a given size is the distribution of sample means. This you call it as sampling distribution of mean. So here sampling distribution, that is for different samples you find the mean. So that particular mean, if you represent it as a probability distribution of all those means of samples, that is the sampling distribution of mean. So this is represented by mu x bar. X bar is the mean, and this is the sampling distribution of mean, and its standard deviation is represented by sigma x bar, that is the mean of sampling distribution. The mean of sampling distribution you write like this, and standard deviation of sampling distribution of mean, you are representing this sample mean x bar. This is standard deviation. This is called as standard deviation of sampling, standard deviation of sampling distribution of mean. So this way you have to remember these terms, so that when you go to the next topic we will be using these terms. So next is standard error. So standard error means this is called, standard error is the standard deviation of the distribution. The standard deviation of distribution of the sample statistic is standard error of mean. So this is denoted by this particular symbol, sigma x bar. So next is central limit theorem. So with this we'll complete this particular unit. Second unit will be completed. So standard error is, it is the standard deviation, but standard deviation of the sample distribution of mean. So next we'll see how to find this standard error of mean. So the standard error of mean is represented by, that is standard error, sigma x bar is given by sigma by root n, that is standard deviation, n is the sample size. So next is central limit theorem. So this central limit theorem, this is a important theorem in the statistical inference. Statistical inference means whatever conclusion you want to come in a particular sample, you use this central limit theorem. So this is, you only remember a particular sentence, that here this central limit theorem, it assures us that the sampling distribution of mean will approach normality. It will approach its normality as the sample size increases. So as its size, that is as the sample size increases, its shape will reach its normality. So the normal distribution of approximation to the sampling distribution, it should be, that is the size of the sample should be at least 30. So if it is at least 30, then the curve will reach its normal distribution, that is the normal curve. It becomes like a normal curve. So this is about the central limit theorem. So the curve will reach its normality as its sample size increases. That is the theorem. So there is no proof or anything. And next is, the next topic is the sampling. In this particular sampling, I will send you the notes. You have different types of samplings. Just go through the theory part. So with this unit will be completed, and tomorrow I will start unit 3. That's all.